What this session is devoted to showing you is to give you the evolution of KantanMT and the evolution of our technology as we start preparing our clients to start embracing NeuralMT. Okay, so remember, we're at the very start of this voyage. There's still things to be discovered in our movement towards NeuralMT, but we're hoping that our clients will get off to a good start by using our platform, and we'll work with them to improve NMT going forward. So our two speakers in this session is Laura and Dimitar, and hopefully you'll learn a lot in terms of the practicality of using NMT and how to compare it to SMT as well. Over to you.
Thank you, Tony. So it's really nice to see such a crowd here. Academia, industry, people from different backgrounds. The session now will be on three parts. So the first part will be about our results with experimenting with neural networks. Then Laura will go over to the quality evaluation, and I will talk after that a bit more about the technology behind the scenes. Okay. So we saw a similar graph earlier today in the morning. Here I'm showing how quality has evolved in time, quality of machine translation. In the beginning, we had the Georgetown experiment with the, I think, 6 or 10 sentences, or etc. Then we had the rule-based systems, phrase-based, hierarchical systems, and now we have this hype, as we call it, or actual results of neural machine translation. What the future will show us, we never know, and we're hoping for the best, right? So Neural came actually last year with a huge breakthrough, triggered mainly by Google, by these guys here, but also the encoder-decoder architecture was designed earlier and presented by now and Cho and Satskever. Sorry if I don't pronounce the names correctly. Sistran also came up with a very nice system last year. But what is actually neural machine translation? After all, it's just another tool to do translation from language A to go to language B. And of course, there are some questions. Is neural better? Is neural faster? How can we compare the quality of different MT paradigms? How can we, and when can we use the one technology, and when can we use the other technology? And of course, the question that we are asking today, and that Andy talked about, and Tony, is NMT better than phrase-based statistical machine translation? Well, simply because we have so many factors to determine this, the answer of this question, we are trying to answer the question: can NMT actually be better than SMT? So can we exploit NMT much better than SMT? Since last year, since actually 2015, there have been a lot of papers presented on comparing NMT and phrase-based SMT results, quality. There is the paper that Andy talked about by Luisa Bentivogli, which is actually a great paper. Also the one of, I think this is by Hugh Huang, who is one of the developers of Moses. That was also a very nice paper that they compared 30 different language pairs. And of course, you have Google's machine translation paper that talks again about comparison between SMT and NMT. Interestingly, in all these papers, there are differences in the way that they are comparing the two architectures, phrase-based SMT and NMT. So we refer to this as comparing apples with oranges, or apples with bananas, or so on. So, and there are other factors. For example, in Google's work, they are training their neural machine translations for, I think, 10 days or something like this, with 96 GPUs for an engine. So that's a great amount of time and great amount of resources. So I don't know what influence it has on the environmental aspect. But, yeah. So in our work, since we started with neural machine translation, what we aim to do is to be fair and compare apples with apples. So again, there are so many factors that we can not be exactly fair, but we try to be as fair as possible. So we took identical training data for both statistical, phrase-based statistical and neural. And we limited the time for training neural machine translation engines. So within the translation production line, we cannot train an engine for 10 days or for weeks. So we said we are going to train neural networks with a limit of 4 days, and that's it. And then we're going to see which of the two paradigms, so which of the different engines perform better. We scored these by the automatic evaluation metrics, F-measure, BLEU, and TER, and we also ranked them with our KantanLQR. We have presented our results in EMT. Everybody who is interested in more details can go to the EMT website and find the papers there. Also, we're going to talk about this in the MT Summit this year, and we also presented some of these results in Lock World, which was 2 weeks ago. And to open a small parenthesis here, again, there are so many factors that determine how a neural machine translation will look like, how the output of neural machine translation will look like at the end. Like, for example, the learning algorithm that is used, the learning rate that is used in this in the architecture, the number of epochs, and you already mentioned this. What are the other properties of the neural network? Is it deep neural network? How deep? How many neurons are there per layer, and etc. And of course, there is the question of data. How do you feed the data? What kind of data are you giving to the network? Andy mentioned we need extreme amount of data for neural networks. Well, I'll add that actually for neural networks, we need the right data. So sometimes with small data, you can train a neural network very well, and it can be a very good neural network, but it can be very specific for the data that you're given. Sometimes with a small amount of data, you can get rubbish results. So all these factors, they play a role in the quality. And as I said, we try to make it as fair as possible. So what we did, we took 5 language pairs, all of them with English as a source language, and different other target languages. There is a reason that we chose these 5 language pairs. So for example, English, Italian, English, Spanish, these are language pairs that for which phrase-based statistical machine translation works well. We have seen this in our experience. Statistical machine translation works well for these language pairs. Japanese and Chinese, these are this is another language family for which statistical machine translation sometimes fails very harshly. And German, that's another challenging language pair, because often, for example, in translating from English to German, phrase-based statistical machine translation, we see that there are so many problems with word order. And sometimes because of the word order of English and German, because they're very different, there are even omissions of verbs and etc. So these language pairs we chose exactly because of these reasons, because we wanted to see under these conditions how NMT and SMT will compare. And you can see these are the parallel sentences, the number of parallel sentences that we took for each of these language pairs, the total word count and the unique word count. All this data is from different domains, so we have legal, medical, technical, and so on. And after training SMT, phrase-based SMT engines with our platform and neural machine translation engines with our platform for 4 days, we got these results. So on the blue side of the table, you have SMT, phrase-based SMT, and on the orange side, you have NMT. I'm showing here F-measure, BLEU, TER, and the time for training. Here, pretty much the same. F-measure, BLEU, TER, time, but also perplexity. What is perplexity? Perplexity is another measurement of how well a model can predict a sample. So a probability model can predict a given sample, a known sample. Basically, it tells us how well the model, in this case the neural model, will predict something that it doesn't know. So for neural networks, we are measuring also this factor. Oh, one more thing to say here, that you see that all of these values here are around 3 and below 3. And in Kantan, with what we have seen so far with neural networks, we have designed this rule of thumb that everything that is below perplexity 3 has actually a useful quality. Of course, that doesn't measure the linguistic quality, but it measures how well the model will actually predict, will translate a sentence into something else. Okay, and the same values are exemplified here. You can see that, let's take BLEU. You can see that the BLEU for BLEU is always higher, which means that statistical machine translation, phrase-based statistical machine translation, outperforms neural machine translation. That was a very interesting result that we were kind of puzzled. Why is that the case? Because we did our tests initially. We saw the output of neural networks, and we were kind of surprised that indeed this scores here, they were in favor of phrase-based statistical machine translation and not in NMT. So what we did after that is to look a bit more in depth of the translation. Here I'm showing some examples, and you can see that actually neural machine translation gives you alternative translations. So for example, the first one is English to German. You can see that these two sentences, they are a translation. So for those of you who speak German, they can assess the quality of these two translations. So this is the reference, this is the source. And you can see that BLEU scores for this sentence, for the phrase-based statistical machine translation system, it scores 58%. We measure BLEU in percent. And NMT scores 0. So BLEU is a metric that kind of says how good the translation is in comparison to a reference. And based on this score, this means that the statistical machine translation output is better than the NMT. If you take a look at the other one here, the other examples here, you can see this is in English, so from Spanish to English, you can see that actually both of these translations, they are very good. And even this one kind of sounds better if you read it in English. I disagree, and I am not in agreement with. But of course, this one here, it's much more similar than the reference, and that's why the BLEU is higher. And we have even this kind of examples where the SMT output, the phrase-based output, matches completely the reference, and therefore it scores with 100% BLEU, while NMT doesn't. So in order to get more in-depth information about this phenomenon, we performed a ranking on the output of SMT and NMT. And what did we do? So first we took 200 segments, and we asked reviewers, professional translators, or professional translators to be, to score the two systems, 200 sentences, and to say if the one is better than the other, or if they're the same, talking about quality. So here in this graph, what we see is that 37% for the English to Chinese, 37% of the segments, of these 200 segments, are the same quality. 24% of the segments are of the statistical or phrase-based statistical machine translation output are better than the neural machine translation output. But when we add neural to the graph, things change. And we see that actually NMT outperforms in all of the cases. Okay? So again, these results are results that we got for exactly this data that we have given. So although our data, our engines are for different languages, for different domains, we cannot generalize these results completely. But from this diversity of the data that we have given, we see that indeed Neural outperforms SMT. And then, of course, we had to take the first results, which are the BLEU results, and the second results, which are the ranking or the A/B testing, and kind of compare them because they were contradicting. So we actually, what we saw is that BLEU underestimates neural machine translation. So that's one of the reasons that sometimes we see different scores and comparing different paradigms, but we don't know whether indeed they're comparable. And what we saw actually when we compared this, the BLEU scores and the ranking, we saw that actually in 48% of the, so that's on average, 48% of the cases where NMT was better, it had a lower BLEU score. So we can say that actually if we take 1.5 times the BLEU of an NMT engine, then we can get some BLEU score that is very similar to the counterpart in phrase-based statistical machine translation. Of course, this is again for these tests that we did, and we need more insights, and we are working on better and more thorough evaluation. And that's what Laura is going to talk about in the next session. To wrap up this talk, so we saw that neuro-machine translation, as we saw it earlier by Andy's talk, does not solve the problem of language, but maybe it's getting there. It has the potential to get there. That's what we see in these graphs. That's what we see with our results. NMT can be much better than SMT. That's something that we also see. It can be worse, of course, but in the plethora of experiments that we did, we see that often it is much better. And also that BLEU TRF measure may underestimate NMT, and when comparing SMT and NMT, we have to take this into account as well. And using KantanLOR, as you will see later on, it's easy to actually perform this kind of ranking experiments. So the question to NMT or not to NMT, I leave it up to you open, and maybe we can discuss it later. So thank you very much.
Hello everyone. I hope you still have some caffeine inside you and you can put up with us with all this plethora of information we are giving you. So I suppose I'm going to talk about the practical exercises and tests and evaluations that we do, and the fact that we do them through our own platform, which is called KantanLOR, which is what you are going to use when we do the ranking later on. Okay? So when I started in machine translation, that was like 2011, 2012, more or less, yeah. Because somebody here in the room who I think maybe might have started with me, or the first time we actually embraced machine translation, we were a bit terrified, and that was that long ago, 6 years ago, something like that. I mean, things have changed so much. And at that time, the question really was machine translation. Well, it was really machine translation. That was the question. And then it became machine translation or translation or traditional translation. I think by now, the conversation has moved on completely. I think more and more people are embracing the technology. We see, I see it with my own eyes because I'm one of the evaluators who did the ranking. Like SMT can be very good, and as we say in Kantan, NMT can be great. So, I think the question is a different one by now. So, let's talk about a little bit like the practicalities of what Dimitar said, which is quality evaluation in production, something that our clients do and that our professional services do in Kantan all the time when they create engines for clients. On an ongoing basis. If we talk about SMT, which is the previous, machine translation technology, the rule of thumb is always F measure should be 70% or more, BLEU should be 60% or more, TER should be 40% or less. I'm not going to go into the details because, if anybody wants more information about it, we can talk about it. This is more or less what we basically want to get when we create our first iteration of an engine. And once it's got this threshold, then we do something else. We evaluate it maybe with our linguists or our clients' linguists. And this is how it looks in KantanLOR. So we have, I suppose, to aid our clients, we have great visualizations, and it's easy to see. We have tips here that will tell you clearly whether your engine has already, reached a good threshold, or if you need more data, you need more monolingual data, your unique vocabulary is too small, whatever it is. Okay? But of course now we have NMT, and as Dimitar has said, NMT and BLEU score don't really, how can I say, dance the same dance? So we have to introduce something else to evaluate our initial engines. So the indicators are indeed still the automatic scores that we use, but we have a question mark over them. We say, okay, and sometimes what we do in many cases with, for instance, Kantan Fleet, we know we have a great Kantan Fleet SMT engine, let's say, and we know that if it becomes neural, it's going to be even better, whether the BLEU score says so or not. We will still evaluate it, but sometimes we work like that. But in this case, the rule of thumb, as Dimitar has said, is the perplexity score should be below 3, and the epochs, which is the iterations, the times the engine, trains itself, if you like, should be between 5 and 9. So that's our rule of thumb. That's what we go by in KantanLOR. Here's another, I suppose, visualization of, when our professional services and Kantan Labs engineers work with NeuralMT engines. This is what they look at, before deciding this is good, or no, let's keep it going, let's keep it cooking. So, but then of course, once we think either neural or statistical, it doesn't matter, is good enough, all the indicators are there, we need to introduce the human value, which, as we've all, I suppose, agreed before, is essential and just as important as it was before, okay? So when do we introduce a human validation? It's at the final stages of engine creation. Let's say we've done all the iterations, the previous iterations, checked all the scores, all the indicators, but then we want a pair of human eyes to have a look and say, actually yes, or yes, but. And also if we are retraining an engine for one reason or another. So to validate, but to improve as well, because then there's still a lot that can be done to improve an engine, and for that we need our friends, the linguists. It is an iterative process, as we've said. That's what we try to tell our clients. You are not going to, you can have a great engine for something if you need it quick, that's fine, but if you really want to get really refined output, there are ways of doing that. So once the engine meets the automatic scores indicators, we'll go to the linguistic feedback with a number of KPIs, which will depend very much on the state of the project or maybe what the output is for. Because up till now, I think most of the time we've been talking about post-editing, but actually one of the great uses of machine translation is basically, to be gisted. For information to be gisted, there is so much information out there, and as Mindagos was saying, we don't have enough translators to translate that, and sometimes it's not economically viable. If there's an e-discovery project with millions of words, you just can't post-edit all this product. So for that reason, the KPIs would be different. One could be, is this good enough? Do I understand? That could be a KPI. Or how is the adequacy? Okay, that could be another KPI. Or I need to see how it deals with terminology. So I want an error classification. Sometimes, if they want to, our error classification is based on the MPWay industry standards. Everybody, I'm sure, in the room knows about them and understands them. So once we get the feedback from the LQR, we apply it into our systems, neural or statistical, and we retrain again. And we do that a few times, not that many, but a few times. And if somebody says there is new terminology that has come in, or something, or the content has gone slightly out of domain for whatever reason, we return it. So for the translators in the room, I think the translator in the room is busy with their baby there, playing on the floor. But anyway, I think this has been mentioned before. That is, they need to be ready to have a different skill set. I mean, they need to be linguists. They need to know their source and target language, the best possible way. But they need to also sometimes. There he is. She's asleep. So I was saying, Javi, that for the translators in the room, you need to add yet another skill on your backpack. I mean, because you are beginning to be almost like magicians of the world as traditional translators. Sorry, and just one more point about that is it's different to post-edit from an SMT output than an NMT output. And what Linda was saying is true. One of the things I think it could happen in Neural is that it reads so well, it looks good, it looks correct. And sometimes it is, but sometimes it's deceivably, fluent. And then the half of the source has been dropped and it's gone. So you really need to be very, very vigilant, and this is a skill that needs to be acquired. Because with SMT, I think the errors are a little bit more obvious. I mean, there can be omissions, but, I think it's easier, or at least we are all used to them. Maybe that's what it is. We need to be used to the NMT issues, right? So anyway, human evaluation with KantanLOR. The aim of KantanLOR is to automate the process of linguistic feedback and quality. And to be honest, we've done all these evaluations with Dimitar. We thought that we couldn't do them in 2 weeks, and we had everything done in 2 weeks, like 15 evaluators. I don't know, it was just crazy. But it's easy when you have some platform that is automated and you get the results actually as they are happening. And sometimes we were so eager that we would be looking at the reviewer, ranking and kind of going, which one was NMT? Was it A or was it B? To see, oh, look, this one is already saying that NMT is better, So the goal, of course, is evaluate or rank or improve engine performance. As I said, there are different types of projects that we do. One of them is ranking, A/B testing, which is what we will try to do later on here. The other one is a straightforward quality evaluation. The KPIs, as I say, those are some of the KPIs, that can be used: adequacy, fluency, overall quality, error classification, all the list of errors. But then some client can say, I actually want to create my own KPI because my own KPI is, do I understand the target, or can I make a buying decision to, when I read this target, and that's it. I don't care if there's spelling mistakes, if there's not a full stop. You know yourselves. You've all been on review platforms or whatever that this type of information is simply automatically translated, and we all buy because we understand that it couldn't be there if it wasn't like this. There's too much information. And then we can do post-editing as well, and we have a little sneaky way of checking productivity. Look at Tony's smiling already. This is how it looks. We are very proud of it because we just changed the interface a couple of weeks ago. I mean, you are going to have to tell us if you like it or not. If you don't like it, don't say it now. It's sexy, isn't it? Yay! So, we are very proud. We think that you know, it looks simple, which is what we, you know, we are aiming for, and it helps our clients reach what they need to reach. So basically here we have obviously the leader productivity line, if you like. We have the post-editing area, right? Source and target. And we have, the post-editing box here, and then if necessary, we have the KPIs area here with a comment as well. We have great visualizations. I'll show you one now, but we can also download it in Excel and do all sorts of crazy things, you know, that you guys do to present to your clients, etc. So we have the option of having the Excel downloadable report there. This is one of, let's say this is, I don't know, the other one is about the heavy ranking. This is one of the basically visualizations we have. It's very simple. It's somebody ranking or scoring adequacy for some content type. And it's very easy to see all those are the segments that have been evaluated. And as you know, like many people know, you know, the way we evaluate adequacy and fluency from 1 to 5. So it's very easy to see that this content, particularly, it's of very high quality. I mean, this doesn't need to be post-edited. This might need to be post-edited slightly the same as this as well. So we already see, and then we have it here interpreted, you know, in a percentage that is good quality. For instance, if this was going to be published without post-editing, maybe it would need a little bit of light post-editing, maybe nothing else. As I say, yeah, the reports provides insights into the quality of the edit. This is just you know, another, I suppose, closer look at the post-editing box. The target appears here, so that the post-editor only needs to go there, doesn't need to copy or anything like that. Change what it needs to change and click next. And yes, the productivity bar is there. As we all know, people who have done productivity tests, I started doing a lot of them actually. The way translators or productivity is always ranked is based on the translator's ability to translate as well. So, you know, at the end of the day, they are kind of measured within themselves, if you like, within their own capabilities. And as you see, I'm going to show you some crazy results. I remember once, there was this super translator, super post-editor, I don't know how to call her, it was a lady, and the amount of words she could translate per hour was crazy, but the amount of words she could post-edit, and then we did the quality evaluation, and we thought, she's going to have so many mistakes here, and it was spotless. It was a bit, maybe she was from the same planet as your own one, but they are out there. There are crazy great translators out there. So this is another way. This is like a little, I suppose, snap of our report. And here is the productivity that can be seen. And this is our A/B testing ranking, I suppose, interface, if you like. It's super simple. So if you are going to do it, this is what you are going to see. In this case, is target, is this the source, target A, target B. It could be if you are ranking 3 systems or 4 systems, you could have here D and C and D, okay? And in this case, it's as simple as, is this better? Click, is this better? Click, whichever one is better. Or if it is the same, which in many cases, what we do is we remove duplicates. Because it could happen that the same translator is given in, by SMT and NMT. But still, you might have many segments that are of the same quality, even though the output is different. And this is what Ricardo will see when you are all doing the A/B testing. Basically, is the results we get. Again, very simple and very easy to understand. In this case, this is one of the evaluations, the ranking we did for the paper, and B was neural. Some of the segments were the same, and A was statistical. Okay. So I'm going to talk a little bit about the evaluations we've done for Neural and the evaluations we are going to do for Neural. I don't want to dwell on this one because Dimitar has already talked about it, but it was clear enough to us two things. One, that Neural was always better, pretty much. Like there wasn't anybody out of the 15 linguists, including me, 5 languages that said that SMT was better. But it was a very open question. Just tell me which one is better. That's all, you know. 5 language pairs. Of course, we wanted to get a couple of different language families there. We didn't get the Slavic languages or the Baltic languages, but we have you, Dimitar, or Mindaugas, so we might ask you to give us feedback on those because those are so important as well. We just went for the I don't know, for the bigger languages, if you like, which is Chinese, Japanese, as you all know, German as well, which are complex languages and they throw problems in SMT. So we have an ongoing test, and I'm just going to give you a little, I suppose, overview of what we've seen already. And what we do is, because we can evaluate for 2 languages in the office, Italian and Spanish, what we do is just to make sure that the test, it's okay, it's not too long, it's not too short, you know, we do it in-house, and then once we know that is correct, we send it outside to the other, you know, and we do the other languages. So in this case, we've done an adequacy and fluency test for 2 language pairs, 50 segments. I did myself 100 segments, just to see if 50 was going to be too little, but actually the results were the same, so we decided to go for 50 segments. And we've done 2 reviewers per language in-house. So fluency, I suppose, is not a surprise that the quality is better. As you can see, the SMT is very good. It's just that the NMT is better. You know, in this case, like, I mean, the scores are great for both of them. Those are our fleet engines, really. That's what we did the ranking on. And I suppose the great insight here, to me at least, is that 3 out of 4 evaluators thought that NMT was more adequate as well. You know, not only fluent. And that for me is a great insight because, you know, we know that NMT is good, but how good, you know? Can we trust NMT as well in terms of carrying the meaning as well as sounding so well and reading so well? So for me, that's a great insight already. Obviously, we need to validate it. We need to do it for more languages and see if things change. So fluency and adequacy scores are higher for Neural, you know, in this case. So productivity test, of course, at the end of the day, we can do all this error classification, adequacy, fluency, you name it. At the end of the day, once again, as we've been talking about it, the end of the equation is the $sign, the euro sign. You just want to see, do I invest in this technology? Because what do I get back? I mean, am I going to get back, you know, enough to make an improvement, to reduce, you know, my cost, increase my margin? This is, at the end of the day, what we are all looking for, apart from the researchers maybe. But the industry, that's what they are looking for. So, and we see crazy results here already. Like, I mean, there is a clear outlier who can do kind of 600 words, can translate 600 words per hour, and can post edit 3,400 words per hour from SMT. I mean, I saw this yesterday and I couldn't believe it. I can't believe it because I've been exposed to this type of crazy data. And then she still manages to improve on NMT. So everybody improved on NMT. Everybody improved from let's say, straightforward translation to SMT greatly, actually, greatly. But then there was still a good, you know, increase on NMT. So those are the percentages of increase between SMT and NMT. So I suppose this is the game, okay? If anybody is thinking, should I actually, invest on NMT or not? Well, we see this. We still need to look far more in depth, indeed, but we already see this. One point, we see this on very easy languages that we know, well, very easy, but the quotation marks, but that we know they do so well in SMT. So my hope, my personal hope, is that when we do this test for German, the actual jump between SMT and NMT is going to be greater. I might be listen a little my heart if it's not the case, okay? But that's my hope in any case. So what's the average increase from translation now to NMT? What's the gap? What's the big, gap? What's the savings? We take the outlier out because it will just throw all the numbers off, and you need to do that in the industry. You just can't, nobody else is doing the same thing as this lady. And one caveat, we haven't fully checked the quality for anything. So still, obviously, we need to finalize this big project and do it, fully. But those are great insights already. So this is the gains from translation to NLP to machine translation, if you like. I know that there are many caveats. I know that if you have tags, if the content is beautiful for NMT or SMT and is full of tags and the system doesn't fix the tags or doesn't put them correctly, all your productivity goes into fixing tags, and then you have a translator who is as annoyed as, because they can't do their magic, they have to be fixing tags, which is what they hate most. But, I hope this figure stays with you guys, and that's why I think that the conversation is not between whether to machine translate, but how to machine translate. So, I'm just, final slide, I think. This is what we are doing at the moment. This is our roadmap for, all the research we are doing. It's very lengthy. We threw every question we could think of into this. You are not supposed to be able to read it. It's just, for you to see that we really work on. Olga, relax there. It's simply for you to see that we are doing it in a very kind of thorough way. We are asking a lot of questions. We are asking questions like, crazy questions like, okay, when an evaluator thinks that SMT and NMT has the same quality, which one is more productive? Is NMT still more productive? Because the errors that NMT throws are easier to fix, or not, or the other way around. NMT all of a sudden drops a piece of content and somebody has to go and find this or research this, and it takes longer. So these are the type of questions we're asking ourselves. So ongoing evaluations related to error classification. We haven't shown any today because we haven't got there yet. Productivity, indeed. Terminology, which is so important for the localization industry, as we all know. And exactly, my favorite question, I suppose, would be which type of productivity increase we can expect in complex languages with NMT, if any, or maybe not. And stay tuned, we will publish the results sometime in the future. And that's all for me. Thanks a million.
5 minutes to talk about how we train neural networks, NeuralMT engines in 4 hours. Okay, it's a bit tight, but let's talk about it. So, as Andy said, we have to take care of the Earth, right? Of the environmental aspect. So we don't want to spend 4 weeks training on high-powered GPUs, neither 4 days. So we want to go down to 4 hours. Both for the Earth and for other aspects. So what is NMT? NMT is this, this. That's actually the Google Neural Machine Translation graph. But I'm not going to talk about this. I'm going to talk about a rather simpler representation. So you have an encoder neural network which takes your sequence of tokens, encodes them into this vector here, vector C, and then another neural network which is called the decoder. It takes this vector C. It starts from the beginning, from an empty sentence, and it adds new words predictively, and tries to generate at the end a meaningful sentence. That's it. It's simple. Encoder, decoder. How do we represent this data? How does this data look like in these intermediate stages and in the beginning in the encoder and then in the decoder? So as Tony mentioned in the morning, now we're not talking anymore about words. We're talking about numbers because neural networks are mathematical models. So we're talking about vectors that represent numbers. And the sequence of different vectors, so here in this case, x1, x2, and x3 are actually corresponding to a word. So, for example, x1, x2, and x3 can be the words John respects Mary. Okay? And then once this sequence of vectors is encoded into this representation C here, it actually can be distributed in some multidimensional space because we're talking about matrices and vectors, which are multidimensional. So not 3, not 4 dimensions, but rather very big. So that's it. We have sentences represented as vectors, and we have this architecture which translates in between these representations. So based on this insight, what do we need to build a neural machine translation engine? So we need the hardware and the software, which is GPUs, the hardware, and we have Torch and Theano and TensorFlow and other frameworks which allow you to build neural networks, artificial neural networks on GPUs. But of course, nowadays we have much more sophisticated products, software products that allow you to directly build neural machine translation engines on top of this software. Of course, for that you need good data, you need your training data, and you need know-how and support. So we need people that will actually help or will train neural networks with this architecture and this data. And of course, on top of everything, you need a way to distribute or to deploy this neural machine translation solution into a translation production line. And KantanMT, it is on top of this, and we provide to our clients all these layers in a simple way. So you don't need to know about GPUs, you don't need to know about OpenNMT. You can take KantanNeural and just build your neural machine translation engines. So how did we start? We started in November last year, and we had to decide how are we going to build neural machine translation? Where are we going to train them, the physical aspect of the platform? So KantanMT is distributed on the cloud, therefore we had to go fully distributed on the cloud. We got some machines from AWS with this specification, so GPUs K520 of NVIDIA. And we installed the two Nematos, which Andy mentioned in the morning, which allowed us to build neural machine translation in 4 weeks. 4 weeks. So you start, you go on holidays, you come back, and hopefully it's ready. Interestingly, the quality was good. It was, we were impressed. I remember Tony and I, we were reading the segments that were coming out of the engine, and they were great. They were just super interesting to read. Let me tell you about two other things: the learning algorithm and the way that we're representing sentences, actually tokens. So now, in phrase-based statistical machine translation, we're talking about n-grams, words, and then phrases. Well, in neural machine translation, since we're taking care of the whole sentence, we have to represent this sentence in a more fragmented way so that the neural network can learn more specific differences between the different sentences. So for languages like English, German, so all these single byte character languages, we are using BP, byte pair encoding, which means that it will split the word in something like this. So lower it will cut it to several parts, and then it will use these words to generate later on different other words. For Chinese, Japanese, we use single character encoding, which means that we split on every character. Then 4 weeks for us was too much, so we switched to OpenNMT, which decreased the training time down to 4 days. And again, the quality was very good. And we started building our NMT fleet. Later on, in March, we had our beta version, which was released, and our clients could build their own NMT engines without extra cost. So we had our NMT platform, so it was free for our clients. And we extended, and we're still extending the Kantan NMT fleet. And today, we have the ability to build your own engine, to get data from our Kantan fleet. And we have better GPUs, which are 2.3 to 3 times faster. And we have these special things, adaptive MT, which allows you to adapt the machine translation engine, and incremental, which allows you to incrementally train the NMT engine. And so, can we do it in 4 hours? Well, you have to experience it, basically, to see whether we can do it in 4 hours. And Kantan, that's it. That's Kantan. As Tony said, we do 3 things: build, improve, and deploy. And because of the full-featured platform, we have done these things. We do these things very efficiently, very well. And for NMT, we had to build our architecture, our system. Because the system is very modular, it was relatively easy to just plug and play, to stick Neural over there. And we have this simple conditionality here. If the engine is going to be Neural, just create the necessary dictionaries and build your NMT with OpenNMT. If it is statistical, just keep on the old or the currently established pipeline. How do you train an NMT engine? So you can actually get an NMT engine from the fleet, and then if you want, you can adapt it, you can incrementally train it, or you can create your own NMT engine from scratch, from zero. Or you can convert an SMT profile. So these are the 3 ways. So as we said, we build engines and we improve them and we deploy them. Just some screenshots about how you can get a Kantan Fleet engine. So you can click on this button over there in our interface and then select a NeuralMT engine. Choose the language pair for which we have NMT. And at the moment, if I'm not wrong, we have 18 language pairs. 24. Oh, 24. And then that's it. And the engine is already in your platform, in your interface. You can use it and so on. If you want to create a blank NMT engine, it's as simple as the statistical. I will not go into details here. You just click next, 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 and then at the end create. It's because Palumi says that we don't have time anymore on this. Later on, if you want, we can show you more in details. And converting a phrase-based statistical machine translation into Neural, it's just actually 3 clicks, I think. You click on the edit properties, and then you click this box here, and you select from statistical to Neural, and that's it. Of course, you have to retrain the engine because it just doesn't go automatically from statistical to Neural. But it will be with all the data and all the PECs or tokenization exceptions that you have incorporated in this statistical machine translation engine. One more thing, and I will wrap up the presentation. As I said, Neural machine translation is iterative. So it executes this loop, very simplified, of course, this nested loops actually, in order to train an engine, which allows us to have these cycles of training and retraining. And that's how we have built our incremental retraining capabilities in Kantan. So you can get your data, the new data, or the post-edited data, stick it to your engine that has already been built, and just click build, and it will actually increment this engine. This we do automatically. So once you train your engine, it is already incremental for the next train or retrain. If you want to switch this thing and reset the engine on every build, you can go to the properties and just switch the button, and then the next train, it will be from scratch. OK, and of course, we have all our capabilities to connect. We have the API, you have the connectors to Trados, to MemoQ, MemSource, and etc. We have the Kantan widgets. Yeah, cross. Yeah. And that's it. Compressed version. Okay, so KantanMT is a complete platform that gives you SMT, NMT. It's easy to access. It's easy to build engines. It's a seamless switch from SMT to Neural, and we have the incremental and adaptive capabilities. 4 hours? Well, for some engines, yes. For some, of course, you need a bit more, but we are getting there. Oh, these are the future works, and as Laura mentioned, there is a lot of work to be done. It's not finished. We constantly work on new things, new features, and research new ways to improve our product. So terminology, tags, non-translatable assets. These are the top priorities. Then we want to link the OQR and the KantanMT so that we can actually do this much more efficient incremental retraining, and so on and so on. We have been thinking of convolutional neural networks and hybrid models, etc. This will come hopefully the next KantanFest. Thank you.